Welcome students. Now we move on to the next concept. Welcome students. Now we move on to the next concept called strings. First we see the definition of the strings. A string is defined as a collection of characters enclosed in double quotes. A string is a collection of characters enclosed in double quotes and terminated using a null character. The syntax to create a string variable is char followed by string name followed by the size enclosed in square brackets. It looks like a character array, but the string is also considered as an array of character locations, but there will be a special character ended or placed at the end of the string value. The example for this string declaration is char followed by a of 10. It means that a is a string variable that is meant to store a maximum of 10 characters. So the size allocated to the variable a is 10 bytes only. Here, out of all these 10 bytes, the character variable, this string variable is going to store only 9 characters, and that extra 10th byte is exclusively meant for holding the null character to indicate the end of the string variable. Some of the salient features of the strings are %s format specification is used to read and write a string through the standard IO statements. The ampersand symbol is not required before the variable name in scanf function while reading the strings, because the string is itself will act like an implicit pointer variable, thereby the location where the string has been created, at that location the variable is going to get the data value entered by the user. So there is the name of the string variable itself gets the address of the string variable. And finally, each string is terminated by a null character. This is the most important one. Of course, we need not have to specify or enter the null character at the end of the string. Here, \0 is the null character which indicates the end of the string. Wherever the \0 is included inside the content of the string variable, the system treats that particular location as the end of the string, and the printing is done up to that point only. Next, the character strings. A sequence of characters is often referred to as the character string. It can be any sequence of characters. A string is stored in an array of type character ending with a null character. One of the examples I am providing here, the beginning of the string is h and the end of the string is \0. As we have seen just now in a previous slide, that null character is the end of the string. So here, this is the end of the string and this is the beginning of the string. Next. A string containing a single character takes up 2 bytes of storage. These are the examples. If h is the only character that is stored in a character variable, it requires or it occupies only 1 byte. A string variable is created and is stored with only a single character like h, then there will be an extra character added to that particular character called null character, and it occupies 1 byte. So a string with a single character will occupy 2 bytes of storage space, and that null character is entirely empty string. The character strings are: the end of the string character is \0. Here it is an array of characters only, but not the string. That means a sequence of characters are stored in consecutive storage locations, but it is not treated as a string because there is no end character available within this particular string variable. Next, char str of 11 is the length of the string variable created, and suppose that we are storing good day as the value in this particular string variable. Good day requires 2, 3, 4, space 5, 6, 7, 8. So totally 8 characters are required, and one more extra character called null character. So the good day, to store this good day, it requires 9 bytes and the remaining 2 bytes are not used. Part of the array but not part of the string. Wherever null character is entered, the system treats this is the endpoint for the string and ignores the remaining storage locations created for that character array. Next, character versus string. A string constant is a sequence of characters enclosed in double quotes. So we enclose the string constant always in a double quotes like this. Char s1 of 2 is equal to a, which is enclosed in double quotes. If we enclose this in single quotes, it is treated as a single character. Now, when we try to enclose a character in double quotes, it internally assumes that it takes 2 bytes of storage space, and like a and \0, where a is the storage location, sorry, a is the alphabet stored in this particular storage location, and null indicates that it is a string. On the other hand, the character in single quotes is only a single character. Here s2 is a single variable name, is of type character, so it requires or it occupies only 1 byte of storage space and takes only 1 byte of storage. So a is stored in s2, and note that here \0 is not included. Next, here a is a single character, a enclosed in double quotes is a string, and nothing enclosed in double quotes is also a string but is treated as a null string. Now, initialization of a string. As we initialize an array variable, as we initialize an integer variable or character variable or any other type of variable, we can initialize a string using the syntax char followed by string name followed by the size enclosed in square brackets followed by string value enclosed in double quotes. Here, one example we provide here as char str of 50 is equal to Visvodaya. That means str is a string variable created with 50 characters length and is initialized with the string is Visvodaya. Here it has 9 characters and the total number of bytes used for storing this particular string in this str is only 10 bytes, and the remaining 40 bytes are freely available. They can be used for storing the data later. Next, the initialization of a string. Here we have a simple note point. Strings can also be initialized in the form of character array. In such cases, it is necessary to add the null character at the end of the string value, that is here. You can initialize the string either by using this array of character locations enclosed in square brackets, curly braces, and at the end we must specify the null character because the computer doesn't know what is the end of the string. So here char str of 10 is provided and the characters are enclosed in single quotes separated by comma, and at the end we are using this null character. So P, B, R, B, I, T, S followed by null character. Here the total number of characters is 7 plus 1, 8. So here str of 10 bytes are created for str. In this 8 bytes are occupied by this PBR bits followed by null character, and the remaining 2 bytes are available freely. Here we should make a simple important point, or we should be remembering one simple important point. The initializer or the string that we are trying to store in the string variable, the size of that string variable or the string constant must be less than the value or the size of the string variable. Because if you try to store the string or string constant beyond the limit which is set for the string variable, then the automatic truncation will take place inside the storage. The next slide. Note, a string can also be initialized by omitting the string size. This is the third way of initializing a string variable. In such cases, compiler automatically allocates sufficient memory for the string by counting the number of initialized characters. As an example, char str, generally we use the name of the string variable str since it starts with str only. Str empty square brackets. Here empty square brackets means it is not a null string. It is a string variable whose size is equal to the size of this string constant that we are initializing. Here HELLO, 5 characters are there. So the size of this str variable will be 6 characters. That means 5 characters of the string constant plus 1 character for extra null character. So in total, this str will occupy only 6 bytes. Later, we cannot increase the size of the string variable or we cannot decrease the size of the variable. The input and output function, that is, whenever we are trying to store or we are thinking about a data variable or an array or a structure or a pointer, in any one of these cases, we will be considering 4 points basically. First is the definition, how to declare it, the declaration, the syntax, like, then how to initialize it, how to access it, and finally, what are the IO operations that we can perform. So here, the input operation on the strings is performed either by using the string-oriented input function getS, or we can use the scanf function to read the string from the user along with the %s notation, as we have seen in our first slide. GetS is a library function which is used for reading an entire line as a string, including blank spaces, until the new line character is entered. That is, the enter key is pressed. GetS followed by string is the syntax that we need to follow for the syntax, this particular string variable. GetS of the name of the string variable. GetS of str will read the string from the user and store in str until the enter key is pressed. The output function. The input is received using the getS function, and putS is the second function that is used for printing the string with any disturbances. PutS is a string-oriented output function which is used for printing an entire line as a string, including blank spaces. And it has a special feature that putS will display the string. Along with that, it will be inserting a new line character at the end of the string. So putS of str will print the content present in str on the screen. At the end of the display, the control will be taken to the next line to display the output of the next statement automatically. Then we have some programs related to this particular simple basics concepts. Let us see them one by one. The first one, write a program to print the length of a given string without using library functions. Without using library functions, we can print the string content by using the simple syntax. Here, str is the string that we receive as parameter from the user. Here note that an array of characters are passed to a pointer variable. Here this str will act like a string variable itself. An integer variable is declared of type integer variable is declared to receive the length of the string. Initially k is initialized to 0, and we will be processing the string until the null character of the string is reached. And each time this particular condition is true, the value of k is incremented. Note that here for loop is terminated using semicolon. It means that the control will be rotating within the same statement until this condition becomes false, and at the end the k will receive the total length of the string, so it will be returned to the main function. Let us see how this particular function will work through our C editor. I am going to type the program and then we will be executing the program properly. Now we have the screen. Let us first type in the program. The comment entry we will be first giving, which says program to print this length of the string without using library functions. First, as usual, hash include stdio.h, standard IO statements, stdio.h. Next, hash include conio.h. Next comes is void main. Since I am using the C++ editor here, I need to use void main because every function should return a value in this C programming. I mean, turbo C++ environment. First, I declare a character variable char followed by str of 25 length, comma, I'm using a variable called I. I is a variable that is declared of type unsigned character, signed character, which can take the value between -128 to +127, as we have learnt it in data types concept. Then first, I clear the screen as usual. I would like to read a string using the printf statement. I would like to give the message, enter any string, quotations close, comma. Then I would like to read the string using getters function, as we have seen just now. Getters of str. First, I would like to print the string printf. Printf. The string is, I'd like to give printing statement printf %s quotations close \n followed by semicolon. Sorry folks, I have to give the name of the string variable. I have given it. Then so put as, I would like to, here itself I have printed the string. Then I would like to find the string length. Put as finding length, quotations close semicolon. I'm giving a getCH statement, or let us go with something else like system of pass. There is a statement system of pass which is used to make the screen wait until you press any key. Then I do the process for I is equal to 0. Just now we have seen the logic to find the length of the string. Str of I not equal to \0 enclosed in single quotes, comma, I ++ semicolon to enter for loop. Within this particular statement itself, the control will rotate, and finally we will be printing the statement. Here the length of the string is, let us go with %alpha_id, quotations close, comma, I, bracket close, semicolon, enter. getCH to display the output screen or wait the control until we continue the process. Let us see how the process continues. %alc, compile. There are two errors. Let me find. So here, system of pass is not supported in our C++ environment. Okay. So there is a mistake called semicolon is missing in this case. Let us clear this line. Let us go with the getCH statement again. Just to make you that we are going to process that string. Let us say again, compile. Yes, there are no errors, successfully done. Then Alt-R, run the program. Program is under execution. Enter any string. Let me enter TBR space VIPS followed by enter key. So the string we have entered is TBR width, finding length. It is going to display. After that, the length of the string is 8 characters. 8 characters including the null character. Actually, TBR space width has only 8 characters. Of course, it is 8 characters. The program is over. Fine. Now let's back to our presentation. So next, we have another program to copy the string from one string to another string without using library functions. Again, the same process. str1 is the first string variable. The second one is str2. Into this string variable, there is a string entered, and that string I would like to copy into another string variable. Just I have added one more simple statement called copying every character of str1 into str2 and finally returning. Of course, it is a simple function. Now let us see again how this program works. So application window, I'm sharing. So the same program, I would like to make the modification. Yeah, here just I add two things. One is str is the first string variable, comma str1. I would like to take the name of the second variable as str1, whose size is also of 25 characters. The size must be equal to copy the content. Here, instead of this, I would like to delete this and use copy. Copy. Here, while copying, as we have seen just now, str of I is equal to str1 of I is equal to str of I. That means we are copying every character of the string 1 into string 2. After that, we will be printing instead of copying, I would like to say the copied string percentile yes, followed by here I have to use str1. Let us see how it executes. Again, compile the program. There are no errors. Find Alt R, compile and execute the program. Enter any string. Let me first give Venu Gopal. This is my name. Venu Gopal Ghantasala. Enter. So the string I have entered is Venu Gopal space Ghantasala. It has some characters. It is immaterial about that particular character, number of characters present in this string. All these characters will be copied into str2. Yeah, this is the copied string. So finally, the string content from one variable to another variable is copied successfully. Then let's go back to our presentation once again. Next, we go with the next one. Another program to concatenate the two given strings without using library functions. Here, the algorithm, let us say the function is given clearly. Concatenating means adding the two strings into a single string. That is, the end of the first string will be added to the second string, the content of the second string. For this, we require three string variables. One string variable contains one string constant, the second string variable contains the second string constant, and the length of first string and the second string as usual. And to store the concatenated strings, we have another variable called str with maximum size, whose size must be greater than or equal to the sizes of S1 and S2. Then we will be first copying the content of S1 into str. That is, the first string content is copied to the resulting string variable. Then we give a space, and then we copy the content of the second string variable into the first string variable from that end of the character. Finally, we print the value. Let us see how this particular program works. Again, I'm sharing the application window. Let us use the same program code for our continuation. There are two variables created str. Let us make this as 50 character length. Okay. There it has gone. 50 characters length. Followed by str1 with 25 characters length, str2 with again 25 characters length. Then one more variable required to find the length of the string variable, also j. Then first enter string 1. I received the first string. Similarly, let's go with another message. Enter string 2, quotations close, getters of str2. So the two strings we have received. String 1 is, let us print first string. String 1 is printed. After that, let us print the second string also. The string 2 is, let us print the string variable content along with \n, quotations close, comma. Let me give str2 close semicolon. After that, concatenating. As usual, we give the message. Concatenating. First, finding the first string. Str of I is equal to str1 of I. The content of the first string is copied. After that, for semicolon, that means that whatever the size available in I, whatever the value is available in I is continued with the next one. Before that, we have to give a space within the string variable. Let us say str of I is equal to space enclosed in single quotes. Then finally, next one. Here, str2. So here I require one more variable called a 0, j. str2 of j not equal to \0, comma, semicolon, str of I equals to str2 of j, comma, j plus plus. Similarly, I plus plus. You can give many number of incrementation operations along with this. And here it should be str of 1, not str of I. Yeah, finally, it is completed. Then, since we are manually doing this particular process, we have to add the null character at the end of the string. Definitely. Otherwise, it will not work properly. And then finally, we print the value or the concatenated string str. Instead of copied string, I will call it as concatenated string. Now let us first compile the program. Alt C, compile. There are two errors. Yeah, I missed a semicolon at the end of this particular statement. Yes, again let us see. One more mistake. Again we missed. What is that missing? Yeah, I missed equal to operator here. Equal to. Alt C, compile the program. Successfully compiled. Again Alt R, run the program. Enter string 1. Let us get Venu. To differentiate, I am giving Gopal as capitalized. So string 1 is Venu, not displayed, concatenating Gopal. Something is missing. Yeah. So only a simple mistake we have done, that is str1 we have to give. Again, let us compile the program. Yes, successfully compiled. Alt R, compile on the program. As usual, menu of Gopal in capitalized letters. So menu Gopal. After string concatenation, yes, it is done. So we should be giving the space appropriately. Yeah, we missed something here. I plus plus we should give. Since the space is increment is not given, the space is occupied by the next string variable. Let us say again. Yeah, Alt R on the program. As usual, menu. So it is clearly concatenated. Then let us come back to the concept. The next slide. So program to compare the given two strings without using library functions. Here the comparison is done using the same notation as we have done just now. The first character, if the lengths of both strings are equal, then only it is possible to compare the strings. Otherwise, they are not equal. So if the first character of the first string is equal to the first character of the second string, then we move on to the second character position. If the second character is also equal, then we move on to the next position and so on. Otherwise, the termination occurs. Here, the logic is something different. If the first character, the character of the first string is not equal to the first character of the second string, then we terminate the process t equal to 1 and break it. Actually, we should break here. So if t equal to 0, t equal to 1 is assigned, and immediately we are checking if t equal to 0, then return 1, else return 0. So we are terminating the process there itself. So t is assigned to 1 if none of these characters is valid. So terminate and then come back to the case. Let us again do the same process. So the two strings have been received. We have printed the strings. Now comparing. Instead of concatenating, let us say this as comparing. First, the lengths we need to find. J equal to 0, str of 1, something. This is not required right now. So first we find the length of the string into I. Next we find the length of the string variable 2 into the variable j. So j will find or store the length of the string variable 1. This I remove. This also I remove. Next I go with something. The logic what we had seen is any one of the string variable contents we can see. If I equals to j, then only the loop should start. If I equals to j, okay, valid. Any one of the string variables we can consider for semicolon I greater than or equal to 0, or let us take some other variable, say int is k is equal to I, k less than equal to 0, semicolon, k less than I, k plus plus. In this, we need to find whether if str1 of I, here k we should use str1 of k equals to, we have used the reverse logic, not equals to str2 of k. if the first character of the first string is not equal to the first character of the second string, we say some flag is equal to 0, 0, and here I give one more statement called break. So this loop has to be discontinued since the first character is not matching. So here we give semicolon, where we need to create another variable called flag, which is by default initializer to 1, comma flag equals to 1. We initially assume that both strings are equal, and then here I gave the statement. So the loop is terminated here, the if statement is also terminated, semicolon, else you can give a message. Since the lengths are not equal, we can say that things are not equal. If flag equals to 1, index of strings are equal, else because strings are not equal, quotations plus semicolon, enter, and of course this is not required, this statement. Yeah, now again let us compile the program. Yeah, successfully done, there are no errors or warnings. Then next we go with the next one, Alt R, enter. The program is under execution. So the first thing, let us give PBRVITS, again PBRVITS, comparing strings are equal. Next, once again let us run the program for all the test cases. PBR space VITS, PBR VITS. So the strings are not equal. So since the lengths are not equal, it displays the message as the same. Again, Alt R, enter, PBR space VITS, VEC. So they are not equal. Let us say, yeah, initially string flag variable is set to 0, 1. That's why it is displaying as this. Okay, no problem. Alt R, again, Alt R, run, PBR space VITS. Now I gave the same in capitalized letters, PBR VITS. Strings are not equal. So this is how the program of this will work. The next one, program to print the reverse of a given string without using library functions. The library function, without using library function, you can print the reverse of a given string from the last character to the first character, for which first we need to find the length of the string. After that we print the characters from right to left. So printing the reverse of a given string, I would like to demonstrate using again the application window. Let us share it. Now, the same program, let us change. Printing reverse. So for that, we don't require all these variables. We require only one particular string variable. Let us say str followed by I. enter a string into str. At first, let us print the string. The string is this one. Reverse is this one. We don't require this right now. First, we find the length of the string. After that, until the value of I is greater than or equal to 0, it can proceed. I greater than or equal to 0, followed by I minus minus. And I print the character individually. All these statements we don't require. Since we are printing the characters one by one, we need to use the printf statement only. Printf quotations open, percentile C, quotations close, comma, str of I. Yeah, open, closed. Now let us compile the program. There are two errors. Let us find what are they. Yes, str1 is given here. It should not be there. Then these statements we should not use since we are trying to print the reverse of a given string only. Now again compile the program. Yes, there is an error still. Here again we made a mistake to find the thing and alt yes, alt R run the program. Yes, let us give the program name. Suppose P B R space B I T S. Reverse is missed it. Oh, sorry. I'll give semicolon here. Alt C, compile, Alt R, run the program. As usual, PBR space BIDS, STIVRBT. Now this is run completely. Then let's back to our presentation. Closes. This next program to find whether the given string is palindrome or not. So first we read the first string. Here palindrome means whether the first string and the second string after reversal is also equal, then we consider the string as a palindrome. So first we find the reverse of a given string and we compare whether the reversal string is equal to the given string or not, then it is palindrome. See, L equal to 0, that is length of the string variable. H is equal to str_len of str minus 1, that is the first string length is found. Then we compare whether the first character of the first string is equal to the last character of the first string or not. So only a single string variable is considered, and in this single string variable, the first character is compared with the first character. Let us consider, let me show you this with a simple pencil notation. Let us say that S T R I N and G. So the length of the string is 6 characters. Here H will get 6 characters as the length. Then all these characters are compared. Here H greater than 0. So the value of L is 0 now. H greater than 0. 6 greater than 0 is the comparison we are making. Yes, the condition is true. str of L plus plus is compared with str of H minus minus. That means str of L plus plus means yes, this is L initially and this is H initially. So str of L plus plus is now compared with G. So S equals to G. S not equal to G, then this string is not a palindrome and terminate the process. Otherwise, let us do in something differently. Let us say A, B, B, A is the string entered. Here, L is initially placed here and H is initially placed here. The length of the string variable here it is 4 characters. So H greater than L. So if H is greater than L, this process is repeated. Here, the number of comparisons is reduced by taking only half of the string. So first, L++ is compared with H-. Both are post decrement and post increment operations. A is now compared with A. A equals to A. Yes, true. So since it is true, the control moves. It can not equal to. Here it is given as not equal to. A not equal to A is false. So control moves back and again the condition is treated. Now the value of L is incremented and the value of H is decremented to B. Now again B not equals to B. We are comparing. Here this condition is also false. B not equal to B is true or false? Is it false? So it is false. So the control comes out. Next, the values of H and L will interchange. H will come down here and L will come down here. This is 0th location, first location, second location and third location. Now the value of H is 2 and the value of L is 1. 2 greater than 1. Sorry. L is here. Yeah. 1 greater than 2. The condition is 1 greater than 2 is false. So control comes out and prints it is palindrome. Yeah. Next. Thank you.